Hello, so in this video I will be discussing code forces around 979 rated for division 2. So I will be solving first four problems of this set. Let's start with problem array, that is a gift for someone, this person. Okay, so in this question we are given a array, okay, of size n, and we can use array A to construct two more arrays B and C such that both contain n elements in the following manners. And what is the manner? That B of I is the minimum of A of I till A of 1. Okay, and similarly C of I is maximum of A of 1 till A of I, right? So we define a score as difference between C of I minus B of I, and we will add it for each and every I, right? So this is the summation. So what is the, so like we can also shuffle our array a initial array A in whatever manner we want. So we have to find the maximum score possible after shuffling the elements optimally. So what is the answer for this? So the answer is pretty much straightforward, but like I will tell you how. For example, I will, if I take this case like 1 2 3 4 5 6. So tell me how you can shuffle the array such that you get the maximum score. And remember, the score is C of I minus B of I and summation for each and every I, right? So to get the maximum score, we want my C of I to be maximum, right? And my B of I to be minimum, right? Right. So like if I make my first element as maximum 1, okay, I make my first element as maximum, okay, done. Now you will notice one thing, that for each and every corresponding I, my C of I would be the maximum only, right? My C of I would be maximum only. Now, but I also want my B of I to be minimum. To make B of I to be minimum, I will like put the maximum element in the front, and I will make rest of the elements in the increasing order after the maximum element, like 1 2 3 4 5. Okay, so what will happen for each and every Ci? My C of I would be maximum, that is my 6 only, which is the maximum element of my array. And for each and every corresponding number, it will be minimum. So minimum number is 1 only, right? My minimum number is 1. So for each and every position, like for example at my point 0, my score will be 0, okay, but at this position it will be 6 minus 1, that is 5, right? And for each and every corresponding value, the answer would be 5 only, because minimum value won't be get minimum and maximum value won't get a maximum number. So that's how you can solve problem array. Just sort the array and put the last element in the front of the array. That's it. If I show the code is also very easy. Just sort the array and insert the last element in the front of the array and just remove it from the last, right? And this is the only operation which is told you in the question only, right? So let's now start with problem B, that is minimize this thing. Okay, so in this question we are given a binary string, okay, and we are also given two functions, f of t and g of t. My f of t is the number of subsequence that contains only 0, and my g of t is the number of subsequence that contains only 1. Okay, so now I have to tell them like what is the, for example, the oneness of a binary string is defined as f of t minus g of t, right? So we have to find the maximum possible value of this equation, or I guess minimum possible it is given. Oh, wait a second, it was minimum, right? To represent, okay, yes, the oneness is as small as possible, right? So we have to find the minimum possible value of f of t minus g of t. So what does this signifies? That my number of subsequence of all of the zeros should be should be equal to, like, or should be at most nearest to the number of subsequence that contains at least one. Okay, so how can we find the answer? So if I tell you, like, just put, if I take example, for example, 0 0 0 0. So how many subsequence will be there? There can be 2 to the power, like, but 1 2 3 4. There will be 2 to the power 4 subsequence minus 1, because empty subsequence is not considered. So there will be 2 to the power 2 to the power 4 minus 1 number of subsequence which contain all of the 0, right? But how to make a subsequence which contain, how to make this much number of subsequence which contain only one? Just put 1 in the starting, right? Because this will make, for example, if I consider only number of subsequence generated by this particular subarray, right? For example, these are x, for example the value of this is x, right? Now tell me, for each and every particular x, if I add 1 in the starting, wouldn't it become the subsequence which contain only one number of one, at least one once? Yes, the answer is yes. Which means for each and every corresponding x, I will get uh, like for example, this is my f function, this is my g function. My g function will also give me this number. My f function will also give me this number, right? Because I have only added one extra one. Because for each and every corresponding f, I will have a corresponding g also by adding one in the starting. Because remember, what is the statement asking you to do? G of t is a number of non-empty subsequence of t that contains at least one. So this contain at least one, right? So for each and every corresponding f, I have a corresponding g also, and remaining one, right? Remaining one, like I can consider it also like the number of g's would be plus one. We can make it plus one also. So I think so this would be as minimum as possible. So the answer in this case would be one only. But how? Like number of f's is this much array, number of g's all is also this much array, but my g contain also one more subsequence, that is a single one. So for the plus one, and the difference between them would be a one only. So that is how you can solve the problem. If n is given to you, just print n. If n is given to you, just print n minus one number of zeros and a single one, right? This much number of one, this much number of zeros, and this much number of one. So just print the answer, and this is your final answer. If I show the code is also easy. So if the n is 1, just print 0 and return. But if else, just print a single one, and from 0 to n minus 1, print zeros. And this is how you can solve problem number B also. So let's now discuss problem number C. This is a true battle. So I think so this is also a very much intuitive problem. I think so a intuition problem. So Alice and Bob are playing a game. There's a list of n booleans, each of which is either true or false, given a binary string of length n, where 1 represents a true and 0 represents a false. And initially there are no operators between the booleans, right? And Alice and Bob start playing the game, and they can place an operator between the corresponding zeros and 1, and the operators are and or. Okay, with the Alice going first. So there will be total n minus 1 operation, because there will be n minus 1 places between the uh, integers also, right? So Bob Alice aims to finalize the statement with the true, while Bob allies to finalize the statement with the false. So we have to find whether the Alice wins or Bob wins. If Alice wins, print yes, else print Bob. So how can we evaluate? For each and every AND operator, you have to evaluate it first. Like if the statement contains an AND operator, choose any one of them and replace the sub expression surrounding it with the evaluation, right? It means first of all you have to evaluate all of the ANDs, and then you have to evaluate all of the ORs, right? So how you can solve the problem? For example, if I take example this only, let me make a constructive example. For example, this is the thing given to me. Okay, first of all, what problem is asking you to do? For example, this is 0 1, and each of 0 represent a false and 1 represent a true, right? So I can either put and it between them, or I can either put or between them. Okay, hope you understand the symbols, right? This is or, right? Okay, so if I put and over here, or over here, and over here, or over here, or and also and over here. So how I will evaluate the situation is like, first of all I will resolve these two, and these two. The corresponding like evaluation, after the corresponding evaluation I will solve like the rest of my remaining pairs of ors, right? So that is how I have to evaluate the expression. So but how to solve this problem? So if I give you a case like 0, if I just tell me simple questions first of all, 0 1 0 1, will allies be any like if whether allies, which operator will allies use? Allies want to make all of the symbols as 1, right? So if I evaluate between 0 and 1, what is the beneficial to allies? It is always beneficial to use or, right? Yes, so allies will always use or. Okay, right. And between 1 and 1, it does not matter whether it is or and, or and, it will be finally and only, 1 only, right? For Bob, tell me what Bob will choose. So Bob wants to maximize the false, right? If he wants to maximize the zeros, then he will always choose and operation between them, right? He will always choose and operation between them, because 1 and 0 is always 0, and it does not matter whether you are using and between 1 and 1, or and between 0 and 0, right? So this is the general things. Okay, okay, done. So Bob will always use add and Elias will always use or. So now next, how to solve the equation, right? So there are total n minus 1 steps. Elias will always try to make the corresponding 0 as 1, right? So for example, with respect to Elias, I will use or over here. Okay, done. Now Bob's son. Bob will try to make my 1 equal to 0. So he will add and over here. Okay, Elias would add or over here. Done. Now again Bob's son, she will put like and over here. Now for each and every corresponding operation, it does not matter whether it is 0 or 1, right? So now it is like Elias, so like it will be and or an and. First of all, evaluate all of the ands, right? Okay, and when like, this will become 0, this is or, this will become 0, this is, this part is left, I guess. It does not matter, let it be or only. So make it this is or, this is make it 1, make it here, now make it equal to 0, and this is also 0, this is also 0. Now tell me what is the final answer. The final answer is 1, because the or operations are only left. But why the answer is coming to me, why is answer coming to be or? The answer is simple, because of this operation, these two consecutive ones coming together. If you try to debug, like if you try to uh, generalize the cases, you will analyze it, like for like you will analyze it, like if in a string, if the two ones are coming consecutive, right? If two ones are coming consecutive, then always allies wins. Yes. So then always allies wins. But why is it, why it is happening? Because like after all of the and operations, after all of the and operations, you know one thing, allies will always be able to remove only 1 1, because because Elias is going, because Elias is going first. Elias will save one of his 1. Elias will save one of his 1, right? So to save one of his 1, he will use AND operation over here. And now Bob cannot ever remove this particular 1. If he cannot if he cannot remove this particular 1, then in the final equation of only ors, there would be at least one. There should be at least, there would be at least one present, right? There should be one, there will be one present in the final string of the ors only. If one is present in the string of ors, then answer will be 1 only. So hope you get the point. Like if your string contains consecutive ones, then an answer is Alice, which means the final output will be yes. Okay. Similarly, you can guess it for the another case also. Like if it is a case with zeros and 1. If ending and the first character is 1, then Elias is going first as usual. Elias will save it in the first step only. Elias will save his 1 in the first step only, right? So this is the only three conditions. If there are two consecutive ones, or either first position is 1 or either last position is 1, then answer is Elias, which means answer is yes, else answer is no, right? Hope you get the point. If you show the solution, like uh, if my both the consecutive numbers are ones, then answer is yes and just return. Or if my last number is 1 or my first number is 1, then answer is yes, else in each and every other case answer is no. So that is how you can solve problem number C also. Let's now discuss last problem, QED, which I was able to solve. QED favorites permutation. So in this question we are given a permutation of size n, okay, and he also have a permutation, he also have a string s of length n containing only characters L and R. Okay, so the person only like the permutation in the sorted order, and to sort the permutation he can choose two type of operation. If my S of I is L, then swap P of I with P of I minus 1, which means swap the current index with the left index. And if it is R, then swap the current index with the right index. Okay, done. Now we are also given Q queries, and each and every query we have to in each and every query, if this is 2, which means I have to swap this particular L to R. Okay, if it is 4, right, 1 2 3 4, then I have to again swap this particular L to R, right? So hope and the changes are persistent, right? If you made a change, then like if you made the change, then it will be persistent, right? Okay, the change is like L to R, right? In each, if you make the change in this particular string using this operation, then that change will resist. Okay, this will not be reverted. Okay, done. Now if my current index is L, then change it to R. If my current index is R, make it to L, right? But how to solve this problem? Like, oh, what is the problem? So for each and every query, we have to tell them after performing the operation, whether using these swaps, can I make my permutation sorted order or not, right? So I think so problem statement is clear to you. Let's now discuss the problem statement. Oh, let's now discuss the answer, solution, whatever you can say. So my string is, my array is, okay, just a second. Okay, my array is 1, 4. Okay, it is correct. So my array is, where it is. So my array is 1, 4, 2 and 5 comma 3, 5 and 3, and my respective elements are L, whatever it is, just write it. Okay, done. So now you will know one thing, that like, try to find some of the blockers, right? There might be some blockers. What is a blocker? BLOCKERS. What is this blocker? So a blocker is simply that index which is resisting you to sort the array. And how to find a blocker element? And like, how to find a blocker element? For example, if your current index is greater than I, if my current index is greater than I, okay, if my current index is greater than I, okay, if my if my current index is greater than I, which means my a of I is greater than my I, and my next number is smaller than that, and my next number is smaller than that, which means my, like, you can see it here, that my 4 is greater than I and my next number is smaller than that, right? And you cannot swap that also, for example, this 4 needs to go in this part of the array, right? If I try to break the array in these two parts, where is the correct position of 4? The correct position of 4 is in this particular, subarray, right? Right. So now tell me, can you swap it here? The answer is no, because you can only swap these two, right? This is R and this is left. You can make it to this term or you can make it to this term, right? You cannot contact with this array, right? So the contact is been broken, very much upset. So the contact is broken in between these two subarrays, and this need to be joined, right? Yes, this need to be joined. So this is a particular blocker element. So with respect to this particular blocker element, I will try to find my answer. This is only the intuition part of this array. For example, if I swap this particular index, this will become R, right? I'm making this R. Now tell me whether all of the brokers are set. For example, if this is L, what is the origin position? This can swap, swap with this can swap with this, and this can swap with this, which means these three elements can internally be swapped, right? And these two can be internally swapped, and there is no connection between them. They are blocked, and they're also blocked. But there is also condition. This particular element needs to go in this part of the array, and these are blocked. So this is not fair. You cannot solve the array in this point. So just mark this at, like, your number of blocker elements are increased by 1 plus 1. This is blocker element. Blocker element is increased by 1. Okay, done. But how to unblock the element? Like, if you make it equal to R, the connection between them is rejoined, which means the whole array can be swapped with each and every element. The answer is yes. If whole array can be swapped with each and every element, you can simply print yes and just return. But how to check? I will like show you the code from the now show you the code for the intuition. Just take the input. Okay, done. Okay, done. Now, like, there's also condition how to check. mm, for example, this is 1 2 1 4 2. I guess it should be 5 and 3. Okay, now tell me, for example, this is L, this is R, and this is also L, and this is L. uh, this must be shift with L, this is R, and this is L. Okay, now tell me, these two can be internally swapped, these three can be internally swapped, right? But tell me, this is a block point, right? This is a block point. Can How you will find that there is, and there, how will you find there is at least one element in this particular subarray which needs to go there, which needs to go there. You can find it using a prefix max array. So the prefix max array would be 1, 4, 4, 5 and 5. Okay, and you know at this point this is L and this is R. The point is broken, you cannot contact between them. And if the point is broken and you cannot contact between them, which means this cannot be swapped with this point, yes, and this needs to go there, this needs to go there, right, but it cannot go there, and it yes, this cannot go there. So you can find the you can find the blocker element using the prefix sum array. If your current prefix sum array at ith position is greater than your I, and the your current uh, swap position is L and the next one is R, then this is a blocker element, just mark it as a count. So that is why I'm using a prefix array. Okay, done. Now what I will do, I will make a function. I have made a function, right? This add means like I am increasing my blocker elements, this is means I am decreasing my blocker elements. Okay, initially in the initial array I will find all of my blocker elements in the count variable, right? How I am finding, like for initially I'm running a loop on my initial array using a 1, which means I will add the blockers. What is a blocker? A blocker is simply element whose current position is L and next position is R, and my current position is greater than I. So in this case I will increase my count, which means I will increase my number of blocker elements. This is add, right? Add means I will increase my count. This is for the initial array, remember. I will I will tell you once again why I'm using 1. Like for the initial array I have to count the number of blocker elements. Okay, I have to count the number of blocker elements. For zeroth query I have to find whether the number of blocker elements are cleared by this particular query or not. Okay, that's why I'm adding. 1 means adding the blocker elements. Now take the input of the query, done. Taking the input, right? Now what I will do, I will just try to remove my blocker elements. Okay, done. Now changing the particular value, like if it is L, just make it equal to R. If it is R, make it equal to L. Right, done. Okay, I will find, like before taking the input, I will just move the blocker elements from the particular index. And after taking the input, I will again add my particular blocker elements, right? So if my count is greater than 1, if my count is greater than 0, like if my count is greater than 0, which means my number of blocker elements are greater than 0, which means there are some positions in which I cannot make my array sorted. In that case just print no, else print 0, right? And you might be wondering why I'm doing this step 0 and 1. You know one thing, that for each and every corresponding index, for each and every corresponding index, just try to find the blocker elements, just try to find the blocker and remove them, because there is not any necessity in them, right? But after the swap you have to add it again, right? Because the swap may have changed your may may have changed the position, right? So that's why I'm removing it before the operation and adding them after the operation, right? So you will get the code in the comment section of these 4 problems. So till then, stay tuned to the next one and do share the video with your classmates, soulmates, whatever. So that's it for today's video. Thank you. Stay tuned to the next one.